James is here, so that's good. Hopefully James
But
can join us in the pantheon of Halloween heroes. There we go.
sorry, I don't really have a. I don't think it like puts me in if I don't have a
Oh
webcam running.
no.
So I think I just get sent to the peanut gallery.
No, you're a disembodied voice, which is even better. It's even better. You have achieved peak Halloween presentation power. So
Thank you.
yeah, so welcome everybody to the FPGA meetup for Open Research Institute for October 11th, 2022. We're looking forward to Halloween, as you can tell, and we have plenty to talk about. So there are a bunch of us that are on vacation, and so I'll summarize briefly that Anshul and Evereast are working on an MQTT control plane for the encoder, and there's been some progress there, but it has not been published yet or pushed or anything like that. So I'm expecting updates no earlier than the 20th of October about that work. So in the meantime, I was like, well, I don't really understand how to use the encoder very well, and I'm sure that there's several other people that might also be in the same boat. And we do have two new FPGA volunteers that have asked, like, okay, how do you work this, and where do I fit in? So I did a little bit of work on that, and I'll share it. But I'd like to start off with James to give you the floor. So go ahead and tell us what you've been doing, what you plan on doing, if anything, and then I think that there's some remote labs updates. Some things are happening with the physical plant, so you have the floor.
Yeah, it's not. It's not like something I can brief in depth, but just we've been moving more equipment. It's not been the fastest of process because my school term has started, so I'm continuing back with my college courses. Um, but we are moving equipment into the new physical site, so that is in process. We're getting more things set up, and that's our general report from Remote Lab South.
Yeah, great. I saw some photographs. It looks like plenty of good things going on. So it's not just benchtop stuff, although that will eventually be part of this installation, but it's also some very heavy equipment and some very interesting instruments, outdoor and indoor things. So it's really great to be able to support it. And yeah, if you need anything, let me know. All right, Paul, you have the floor. How's Remote West doing?
It's hanging in there. Updated the software on the Remote South remotely. um, haven't yet updated the software on the Remote West here because I've been using it, but we'll find a window in here sometime in the next couple of days, I hope, to get that up to speed. Otherwise, nothing to report.
All right, very good. Okay, I'll explain a little bit about what we're doing in terms of documentation to show that. Let me make sure I've got the right window open. It looks like I do. And then I'll attempt to share the screen. And yeah. Okay, so I'm going to go ahead and share this. Okay, so this is a block diagram of what's called the top block, or the encoder wrapper. So we have this large like a reference design from Analog Devices that works for the ZC706 and the ADR V9371 board that is physically connected to our dev board. And so there's lots of blocks. It's a whole communication system reference design, and the expectation is that you put in your custom code, and that you get to start your journey of experimentation, verification, validation, development. So we've done that, and this is the encoder wrapper for our particular IP for the downlink. Okay, so what does it really look like? So what I did is I brought out the important stuff, and so we have a clock and a reset, and the reset, there's a note on the reset. It says extended to 16 cycles, so that's kind of important. So we extend out the reset signal on our encoder, and we have data that comes in, which is 32 bits wide, and it goes into our encoder top block, and it gets taken into what's called an inline configuration or config adapter. So what comes out of that block is the data, this data stream, and this data stream is, what goes into the encoder is baseband frames. And so that continues, that data goes through the inline configuration adapter. The first frame of, or a frame, a 32-bit word in front of every frame, I believe, is the frame type, and that's a 2-bit field that tells you that pilots are on or off, and it tells you the length of the frame, so it's short or normal. So those 2 bits control that. The pilots is not yet implemented. So the frame type for the way that we have it deployed right now only tells you whether it's short or normal frames. We are going to use short frames. And then constellation is the modulation picked for that particular set of data, because you can change per frame. And the code rate, the forward error correction code rate. So those things are in a configuration word that's in front of every BB frame that we're sending to our encoder. This comes from the processor. The processor makes decisions based on quality of service or the multiplexing, all of the things that it knows from the uplink, received channels, and possibly requests, all that. So this word, this 32-bit word that the config adapter is interpreting and turning into the signals of frame type, constellation, code rate, is something that we're providing. And then the rest of the BB frame goes through to the encoder. Okay, so the encoder T data there at the bottom, the rest of the BB frame goes through to the encoder, and we interpret this word and we break it down and we give it frame type, constellation, and code rate. And those things are used all throughout the encoder. What comes out of the encoder and what is presented at the output of this encoder wrapper is IQ is IQ modulation. So the IQ signals then go to the transmit, transmit DAC, and off they go to the actual radio. So drilling down into the inline config adapter. So we're going to set aside the encoder, which has lots of complicated stuff in it, and does our encoding. So if we go to the inline config adapter, this is the start of it. It's not done yet. You can see I've got all this stuff set off to the side, but this is what it looks like. So when you go to the inline configuration adapter block, you can see that there's 2 other blocks. There's a width converter and there's a config demux, and we'll drill down into those too. But right now we're just going to consider them as blocks. So what's going on here? It's making lots of decisions. It's looking at clock and reset. It's trying to figure out what the first word, that configuration word. So this block has to correctly identify the first word, and then decipher it. And this is where it says, okay, for this value, I am this particular modulation and this particular code rate and this particular frame type, and then set those bits in those output signals accordingly. So you can see it's not quite done yet, but this is the sort of a drawing that will hopefully help people that are visual learners like me, what's going on. So this will get reviewed and then get put out there as a helper for those that want to use this particular block in their designs, because you have to supply this word. It's to come from somewhere. So lots going on. The width converter and the config demux are utility functions that are in the repo, and they're neat. They can be used in and of themselves to do all sorts of interesting functions. So that's what I've done over the past week, especially. And then I'm going to continue doing this to try to get a complete understanding of what's going on. And the goal of this particular set of work is to get the encoder controlled, like not just on the air, but where we're controlling things and feeding it data, hopefully from a camera so that it's live, or from some other set of files. I did get, I'm going to go ahead and stop sharing, come back to the, okay, so another thing that we're doing is starting to produce the files for the default digital downlink. and whether these are files that are sent over the air, that are recorded like IQ files, or whether they're generated, algorithmically generated. Either way, but starting out, we have a set of files, and this default digital downlink is when there is no traffic, that the transponder goes through every possible combination of modulation and coding. This way, you can tell how good your receiver is. So this is sort of like a constant receiver test beacon being transmitted all the time that you don't have user traffic. And the suggestion has been to interleave the most easiest, loudest signal with the least amount of coding, the simplest constellation, that's interleaved at every other frame if we do these sequentially, or if there's a way to send them all out at once and you can pick the channel. Then you can rotate through, like you can peak up your antenna and handle pointing, get pointing nailed down, and then you can start attempting to receive things that have more complicated modulation and more coding. And then wherever you end up, that's essentially a score for your receiver. So we started working on that. That's what led to documenting the encoder a little bit better, because we have to generate the right type of files to go out over the air, and we had some misunderstandings about how to use it. So that's where we're at for this week. So I'm going to open the floor up to any other additions or questions about FPGA work. Or anything that I missed. Okay, welcome to all of our new participants and supporters. We really, really appreciate it. We're going to keep pressing forward here. On the other side of the system is the uplink receiver. So we've spent a lot of time talking about that, but no further things to report on the simple FSK receiver. There've been some discussions about trying to get a better link budget put together. So some progress there too. But I think getting the downlink transmitter nailed down is a higher priority at this point. So we've brought up the uplink receiver up to the point where we've got some content there and some progress, and that getting the downlink transmitter working will be the very next thing. All right, so that's it from this side. Any other last comments or discussions about remote lab concerns?
Nothing from this end.
All right, thank you very much.
Nothing here.
Thank you very much, James. Appreciate all the hard work. All right, so anyone that has any sort of questions from watching this, please send it on in. And everyone that is interested in making this happen, you are more than welcome to join us. You do not have to be an expert to join, just have to be willing to become more of one along the way. And thanks so much, everybody. See you next week.